Our final learning objective of this kinetics unit is to learn about catalysts. We're going to explain what a catalyst is, what it does, and how it works down on the molecular level. What is occurring that allows these catalysts to do what they need to do. So what is a catalyst? It's a substance that increases the rate of a chemical reaction without itself being consumed. So it's going to speed up the reaction, and however much catalyst you put in at the beginning, that's how much you have at the end. Well, how is that possible? Well, what happens is that substance, that catalyst, reacts with an elementary step that's early in the mechanism. So it is getting used. But later, in a subsequent step further down in the mechanism, it is getting regenerated. So overall, it's being used and spit back out, and you do not see it being consumed. Now, the reason a catalyst works is it is giving you a completely different mechanism than what there was without the catalyst. So it is becoming a part of the elementary steps in our mechanism, and the rate determining step of that has a lower activation energy. So this is a simplification of what a catalyst is doing. Picture A is the uncatalyzed form, and picture B is the catalyzed form. We see that it is lowering the activation energy. Now again, how does it do that? It gives a completely different route for the reactants to get into products. Different elementary steps are occurring, and for the catalyzed form, the elementary step, that's the rate determining step, will have a lower activation energy barrier. Now there are three general types of catalysts. You've got your heterogeneous and your homogeneous catalyst, and then you've got your enzyme. Heterogeneous and homogeneous, we'll talk about them together. They're really defined by the state that the catalyst is in. Heterogeneous catalysts are in a different phase than their reactants. This is what is actually seen in our catalytic converters. Often you have a solid catalyst and a gas is passed through. That's occurring again in our catalytic converters. The exhaust gases are coming through that catalytic converter. Catalytic converter are solid metals that the gas is passing through, and it allows for the combustion process to the oxidation of those exhaust products to occur. Homogeneous catalysts are in the same phase as your reactants. For example, maybe they're all aqueous or all in the gas phase. So that would be a homogeneous catalyst. An enzyme you will see if you take courses in biochemistry, for example. So they are enzymes that are biological. They help catalyze biochemical processes that take place in your body. They allow for these reactions to take place without having real high elevated temperatures. These are often very large and complex molecules with molar masses in the thousands. All the same aspects apply to enzymes that apply to catalysts. They give an alternate route for the reaction to take place. They lower the activation energy. They do not themselves get consumed in the overall process. I just wanted you to see when I say that they are large and complex, each one of those little knobs that you're seeing there are a different atom. So this is a very, very large enzyme that is in the body, gives the name there of that activated enzyme. But this enzyme would be involved in a biochemical process within the body. So this is the end of our kinetics unit. Be sure to view any of the additional work problems that I've prepared for you. Practice those problems in the practice set. Study these notes and make sure you're really understanding what is occurring both on the molecular view of things and on the macroscopic scale. And then when you've done the studying, you'll be ready to take the assessment to show that you understand the kinetics unit.